colligative properties depend on how much stuff is in solution, not on what's in solution. We need to be a little bit careful because ionic compounds dissolved in water dissociate. What does dissociate mean?
Break apart.
Break apart. They're going to break apart into their ions. So most colligative properties depend on the amount in there. So when it breaks apart, if I take NaCl, it doesn't count just as NaCl. It counts as Na plus and Cl minus. So I get a 2 for 1. All right. So if I do MgCl2, how many particles do I have if I have one particle of that? 3. Okay. All right. So colligative properties. We get some neat stuff going on. Before we get into the weeds of the numbers, we will take the boiling point. It gets elevated. Elevated. Boiling point elevation. We take the melting point, which is also the freezing point, right? It gets depressed. It's lowered. While I'm at it, I'm also going to say the vapor pressure is lowered.
So it melts easier and boils later.
It melts easier and boils later. Yep. Yep. Now you've used some of this in your life. If I step outside and it is icy on my front porch, what might I do? Salt it. All right, so I sprinkle some salt on it. It dissolves in that top layer of water. All ice has a little top layer of water, otherwise ice skates wouldn't work. And as it does that, it lowers the melting point. And all of a sudden it starts melting. But it's not heating up that ice. It's actually making the melting point lower than the temperature it is outside. And so now it's warm enough to melt that ice. And the nice thing is that salt water kind of goes down to the next layer of ice as long as it doesn't all run off. Okay. Great. That means there's a lower limit to it.
0 degrees. If it's below 0, the salt won't work on.
If it's below 0 on Celsius or Fahrenheit?
Fahrenheit.
On Fahrenheit. Okay. So that buys us a little bit of time, but after a certain point, it's too cold. Icing it's not going to be enough. Okay, great. What's the problem with icing it or putting salt on the ice? It freezes back. When? When the salt gets run off, or when it gets really, really cold again. Okay. And then as it goes, it gets diluted, so it has less of an effect. All right. What else? Long-term problems. It's what?
Are you talking about like introducing salt to the ground or road?
Sure. What's that do?
It kind of. I know, because I grew up in Ohio, so like it destroys the roads. We have to repave them all the time.
It destroys the roads. Potholes everywhere.
Yeah.
Oh yeah, sure. The salt water gets down in the cracks, and when the water evaporates, the salt forms crystals and expands, completely destroys the road. Okay. What else? Rust out your car. All right, regular water, not conductive. Rust is an electrochemical process. All right. So we have salt water, it's conductive. Now you've got the bottom of your car rusted. If you have never been told this, do not buy a used car from up north. the bottom of it will be rusted. Right? There's pretty much no way around it. They try to sell all kinds of stuff for putting under it, but it's going to rust. All right, so is salt good for plants? No. So you've got all these dead grass around broken roads that you're driving a rusty car on. Okay, that's the problem solved. Plus, it's cheap and expensive at the same time. So because it's relatively cheap, but they buy so much of it that it's expensive.
And it's expensive because you gotta fix the road later.
You got to fix the road. You got to fix people. Everybody's got to fix their cars.
Yeah.
And then people like gripes about how ugly your state is because you drive by and all the grass is dead. All right. So that's the problem with salt water. Now, colligative properties, it doesn't matter what it is. Doesn't matter what it is. So we need something else that we can dissolve in water. It's going to lower the melting point. We need to accomplish some of the goals. We don't want anything that's ionic that dissociates, because then we'll still be getting all that rusting going on. We want something that's covalent, that's not going to dissociate like that, so it won't be rusting, it won't be electrolytic. The problem is that salt, you got a 2-for-1, so you'll have to use twice as much of it, so it needs to be really, really cheap. All right, and then it'd be great if it didn't rust cars, destroy the roads, kill the flowers. Okay, well, it turns out they found a chemical that you can, as long as you bring your own bucket, a farmer will give you as much of it as you want. And it's urea. Where is urea found? In urine, sure. You take that up to a farmer and you say, can I gather some cow urine? And they'll say, sure. And you're on your own, you get your own bucket. Good luck. All right. But it's pretty cheap. It's pretty cheap. And so if we spread that on, matter of fact, you can spread that, already in liquid form. You spray it on, okay? So we spray it on there. It melts the ice. Hey, it doesn't form those big crystals like salt crystals do, so it doesn't destroy the road. And it's actually really good for those flowers. Like in spring, you've never seen prettier flowers along the roads than you do along this one. They tried it for a couple of winters and then they stopped doing it. When did they stop?
Is it Hasselflicker to kill you?
Is what?
Is it Hasselflicker to kill you?
Not really. No, they've got most of those cows just kind of immobilized, and it's just one more tube to stick on them.
Well, if they're spreading it in liquid form, that visually you're gonna get. Would you get the yellow snow still?
You might get yellow snow, yeah.
Yeah. I mean, people wouldn't like that.
No, urea itself is a solid, so we could spray it in solid if people didn't like that. But yeah, you're on the main thing that people have, and they go, oh, it's disgusting. Nobody wants to drive down the P road. Because you get to the end, you've got this slush stuck to the bottom of your car, and you go, hey, at least it's not rusted. Maybe it smells a little, but it's not gonna rust. So yeah, so we're still working on trying to find something else. But so that's why we still use salt, even though it destroys the roads, destroys the cars, not good for the environment. It's just because nobody can handle the smell or the thought of driving down the P road. And we don't have anything that's really cheaper. What would be really cheap is to take all the cows, have them walk down the street, they would plow it, they would fertilize it, and they melt all the leftover ice. And nobody's got that kind of time. And, well, they do have a lot of cows, but I don't know if you've seen any videos of them driving. I wouldn't want to put my cows out there. It's crowded. It's really crowded. No way around them. All right.
Pennsylvania used to, like in the steel, around the steel town, they used to take cinders from the mills, dump them on the roads to melt through the
They took all the hot cinders. Okay.
Because then it was like at least pock market so that you could get traction.
How do we do it in here? We don't always use we don't always use salt.
On the road.
We use sand. Now, the sand is not a colligative property. Why not?
It doesn't dissolve.
It doesn't dissolve. It has to dissolve to be a colligative property. So the sand doesn't dissolve, but it does give you some traction. Okay. All right. Great. So that's this going down. You've used boiling point going up. Oh, let me show you the other thing, this melting point going down. All right, I gotta get ready for the game. I want my beer, but I forgot to put it in the cooler the night before. I throw my ice in, I throw my beer in, put some salt in there. Why?
It'll make it get colder.
It lets it get colder before that water freezes, right? Yeah, now it's colder, it sucks more heat out of my beer. My beer can actually even get colder than it otherwise would have.
Well, be.
Yeah.
It works real well. They get
Isn't
real
that,
cold.
can I make ice cream too?
Yep,
Yeah,
that's how you make ice cream. You gotta have rock salt. All right, now you don't actually put the salt in your ice cream, you put it in the outside layer. It's a two-layer thing. You've used a similar idea for the boiling point. I'm gonna cook some spaghetti.
Yeah.
Instruction said, give me a pot, add some water,
Salt the water.
salt the water. Why am I gonna salt the
See,
water?
I didn't know.
I
My
thought
family's
it was
Italian, so we just salt.
You just throw salt in. Everybody tells me.
Yeah.
Man told me to do that. I thought it was flavor too, but that makes sense. Boil faster.
It boils faster,
Well, you would think, because wouldn't it boil hot?
boils hotter. Yeah, that's
Well,
different.
they cook faster, sorry.
It'll cook faster. Yeah, it's on the right track. Yeah. Because it makes it go higher temperature. So let's explain why. Why does it make it go higher temperature? And this is the same idea behind this vapor pressure. All right, so here's what's going on. I've got my water molecules. And when I add heat, some of them go "Meow," and they go flying up into the gas phase. And when I get this up here, this is our vapor pressure, right? And when that vapor pressure is equal to atmospheric pressure, what do we call that? Boiling. Okay? So now I'm going to add some of these salts. And I got these particles just floating around. Now at the same temperature, some of them are bouncing off. The vapor pressure has been lowered. They bounce off, they lose their energy, and they get trapped back in the water. Right? So we got to apply more heat to get a higher percentage to get back up here to get this vapor pressure to be equal to atmospheric pressure. Okay, so now we've got an issue. The boiling point goes up because the vapor pressure went down. Those are related. And it's just because they're physically in the way. Okay? It's similar to this idea of melting point. Melting point, everything's got to get lined up into the crystals and get closely packed. And if you've got stuff in the way, it slows that process down. So that means our water will be hotter. We can cook the food faster.
So essentially, if you add salt to water, in this case with spaghetti, it takes longer to start boiling,
Yes.
but it cooks quicker because it's a higher temperature.
Yes.
It boils longer, doesn't it?
No. Well, it takes it longer to boil all the way
That's
off.
what I'm
But,
saying. So like,
but yeah, it's just, it'll be at a higher temperature when it starts boiling. So you'll have to add more heat to get it to the point. But now it's got more heat to transfer into a bigger temperature differential, so it'll transfer to the food faster. Okay, and so it'll cook food faster, but yeah, it takes longer to get it boiled.
If you explain that, 'cause I'm like, damn, I thought it was just flavor.
Flavor. Matter of fact, that's actually a problem. Is remember, boiling point has a dependence on atmospheric pressure. So if I go, for instance, to Denver, where I'm at a higher altitude, I have a lower atmospheric pressure, and I get to trying to cook, I don't know, a bowl of potato. That water is boiling at such a low temperature that my potato never gets enough heat in it to really get cooking.
so you need to add salt.
So I add salt, right? But by the time I add enough salt to get that to actually cook the potato, I've been soaking it in that concentrated salt water, and it's inedible. It's just that potato is just too much salt. You won't be able to eat it. The taste is terrible.
That's Subian.
So I can't just keep adding salt. There's a limit to that. And then once we're at the point of it can't, and then I can't just add more heat because we're at the boiling point.
You can see it.
I what?
You can see it, right?
Pea in it?
Yeah.
Yeah, man.
I'll make it salty.
So how do you cook food when you get?
Technically, so you could sous vide, you could create a barrier between the food and salt water. Cause that's like.
Okay.
Package it. So,
Yeah, like-
or pressure cooker.
A pressure cooker. Why a pressure cooker?
Because, it's what we talking about the other day.
We can change atmospheric pressure so that even though we're at lower pressure overall, around that container, it's at higher pressure. Now we don't need as much salt. Then you're adding salt for flavor. All right. But this colligative properties we have used in your everyday life, you've just never thought of it as because of these properties. All right. So we'll get into how high does the boiling point go up? How low does the vapor pressure go down as we add certain amounts of salt, depending on their mole fraction? How much is the melting point depression? Okay, so we got a bunch of math on doing all that, but it's really on these concepts that you already knew. You just didn't quite know what was causing.
I didn't know why I knew.
Didn't know why you knew.